Okay, so let's look at this here. So how can I get from 4 to 16? You could think add 12 or multiply by 4. 16 to 36, I can't add 12 or multiply, so this is neither. Does everybody understand? That would be neither arithmetic or geometric. All right, how do I get from negative 24 to negative 5? Negative 34? Sorry. I would subtract 5, subtract 5, subtract 5. So this is arithmetic. Good? It's okay. I don't care how you say it. I'm recording, so I need to say it right. Okay, so everybody understand how that one's arithmetic? Okay, how do I get from 1 to 5? Times 5, 5 to 25? Times 5. So we're multiplying here, so it is geometric. Okay, how do I get from 1 to 4? Add 3 or multiply by 4. 4 to 9 would be add 5, but I can't multiply, so this is neither. Now this is a series, it's just not one we're doing in this class, okay? There is a series later if you continue your math career that would actually be able to do something. It's just not geometric or arithmetic that we're doing. Yes. All right, so from here to here, what do we do in here? How do I get from 34 to 26? I add 8, add 8, add 8. So it is arithmetic. Everybody good? Okay, the last one is what? Neither. Okay, so we'll continue on that, and then we'll do that on Thursday. I thought if you understood what the series were, then when we talk about how you find it and stuff, it'll make more sense. All right, any questions on your decay or growth problems from last night's homework? I put the answer key, and everybody good on that? Okay. All right, let's look at the last page of your notes for this unit. This will not be on your quiz. You will have an assignment tomorrow with it, though. This first part up here at the top will not be, and then we have a little review that we're going to look at. Okay, writing exponential, what is it? Oh, sorry. Writing exponential equations from a table and a graph. Okay, so what do we know, first of all, about A? A is the starting value. And if there's not a transformation, what is that always on the graph? 1, and it's the y-intercept, right? Yes, that's where we look at for is the y-intercept. But it's 1 if there's not a transformation, right? And then it's located at the y-intercept even when there's a transformation. That allows us, if it moves from 1, to know if there's a transformation, right? Okay. So here is B. Okay, what is B? The percentage. It can be the percent of growth or it can be the percent of decay. Okay, so in this problem here, if I'm looking at this table, what is my starting value? 125, because I look for the y-intercept. Okay, so I'm going to have y equals 125. And then is this function, if I go from left to right, because negative 2 to 2, is it getting bigger or smaller? Bigger. So I know my b is going to be greater than 1. So how do I get from 5 to 25? By 5, because I could do 25 divided by 5, so that equals 5, and then 125 divided by 25 is 5, 625 divided, so my b is increasing at a growth rate of 5, and then x. Does everybody understand that? Okay, let's look at the next one. What is my starting point here? 3, because here's my y-intercept, so my starting point is 3. Is the values going up or down? Up. So how do I get from 3 to 6? Times 2. And 6 to 12? Times 2, right? So you take the last number and go backwards, so like 12 divided by 6 is 2. So this is going to be 2 and then to the x. Does everybody understand that? Okay, so I want you to try this one. You try number 2. Okay, what is our starting point? 6, because we go 0, 6. And then is this one going increasing or decreasing? Decreasing. So if I do 3 divided by 6, I get 1 over 2. So it would be 1/2 x. No, I'd like to use fractions. But if you put 0.5, it's easier to see as a fraction. So unless it's a real life situation, I like to use fractions always. All right. Everybody good with the table? Okay, so when a graph, you want to create a table of values from the graph, determine your B value, the common ratio, like we did there, 6 divided by 12, and the other. The y-intercept is your A, and only include a C value if the asymptote is not at 0, okay? Because that tells us it moved up or down. So let's look at this number 1. We're going to have the point 0, 1, and then we have the point 1, 3. Does everybody see where I'm getting these points? 1, 3, and then 2, 9. I didn't do the negative ones because I can estimate those, but will I be exact on those? No. So I want to do exact ones. Okay, does everybody understand what I have there? Is this growing or decaying? Growing. It is growing. So I have y equals, my starting value is 1, so I don't need to put A is 1, right? You don't normally list that. And then what is the growth rate? 3, because 9 divided by 3 is 3 to the x. Does that make sense? Around the 3? Yes, you can do that. Okay, so let's look at this one together. So we have 0, negative 1. This one's a little harder to read, so I want to make sure. 1, negative 3, and 2, negative 9. Okay, is this one growing or decaying? It is growing negatively. Remember, look here. Don't look at the sign of the number. How do I get from 1 to 3? Multiply by 3. 3 to 9 times 3. So what is my A going to be here? Negative 1. So it's negative and then 3 to the x. So be careful there because the negative 1 tells me my A is negative. And then what is the rate? What's negative 9 divided by negative 3? So what is that rate? 3. So it is, and that helps me know it is a growth because it's greater than 1.